In the beginning, there was almost nothing. No stars, no galaxies, not even atoms bound to one another. Only a restless haze of light and matter adrift in a cosmic sea that was eerily uniform. Yet, from this near-perfect sameness, something impossible began to whisper into existence. From smoothness came structure. From silence, the first murmur of form. The universe, once a featureless fog, was about to dream of galaxies. For a fleeting instant after the Big Bang, everything was equal. Temperature, density, energy, all balanced to absurd precision. A universe without preference or pattern. And yet, that perfection was unstable, destined to fracture under its own subtle flaws. Tiny ripples in the early plasma, fluctuations no greater than 1 part in 100,000, began to stretch across the young cosmos like faint fingerprints on a newborn skin. These ripples were gravity's first sketches, drawn on the canvas of space-time. Gravity, the invisible artist, had waited for its moment. With infinite patience, it reached into the uniform fog, pulling some regions ever so slightly tighter, letting others drift apart. Over millions of years, those minuscule differences grew. Dense patches thickened into clouds. Clouds collapsed into stars. Stars assembled into clusters. And from the gentle tremor of imbalance, galaxies spiraled into being. Vast islands of fire and motion in an ocean of expanding dark. But gravity's dreams were not gentle ones. The same hand that shaped light also sculpted darkness. In the hearts of the first massive stars, where fusion burned too furiously to last, gravity's hunger turned violent. When those stars collapsed, their cores folded space into itself, forming black holes, regions where gravity became pure isolation, a prison of its own making. Light fell inward and never returned. The universe had created its first paradox. The same law that gave birth to radiant order had also forged the darkest voids imaginable. So began the long duel between expansion and collapse, creation and consumption, illumination and shadow. Every galaxy born was a compromise between chaos and harmony, a frozen record of that struggle. And as we look across the sky today, each shimmering cluster, each yawning black hole, carries within it the memory of that first flicker, the moment when gravity dared to turn nothing into everything. In the aftermath of creation, the universe was still too young to know what it would become. Space stretched like a newborn lung taking its first breath, its glow fading from white-hot fury to a dim, reddish haze. The cosmic symphony had quieted, but the stage had been set. Every atom, every photon, every grain of dark matter drifted in near-perfect balance, a still pond after a storm. And yet, hidden within that apparent calm, were imperfections so faint they seemed meaningless. 1 part in 100,000, that was all it took. Within those subtle variations, the entire fate of the cosmos was written. When the universe was roughly 380,000 years old, the chaos of light and matter began to separate. Before that moment, the universe had been a blinding fog. Photons endlessly colliding with electrons, scattering in every direction, erasing all structure before it could form. But as the universe expanded and cooled, electrons finally found protons to cling to, forming the first hydrogen atoms. The fog lifted. Light broke free. What we now call the cosmic microwave background, the faint afterglow of creation, began its eternal journey. It carried with it a fossil imprint of those early ripples, the fingerprints of future galaxies scattered across the infant sky. To the naked eye, the young cosmos would have appeared almost featureless. But beneath its serene surface, dark matter, a mysterious substance unseen and untouchable, had already begun to gather. It did not scatter light or radiate energy. It whispered only through gravity. Where dark matter was slightly denser, it began to pull in more of itself, forming invisible cocoons known as dark matter halos. Ordinary matter, the kind that would one day make stars, planets, and life, was drawn toward these gravitational wells, like dust drifting into invisible whirlpools. The architecture of the cosmos was being drafted by hands no one could see. These halos became the silent scaffolds of creation. Within them, gas began to flow, cooling and condensing as it spiraled inward. The process was agonizingly slow, taking tens of millions of years. Gravity had no urgency. It was content to sculpt eternity grain by grain. The first clumps of matter thickened, compressing under their own weight. Within the densest pockets, pressure and temperature soared, igniting the first stars. These ancient suns were colossal, hundreds of times more massive than our own. They lived brief, furious lives, burning their hydrogen in mere millions of years before collapsing into black holes or exploding in supernovae that scattered heavy elements into the void. This was the universe's adolescence, turbulent, restless, and creative. Regions of space where gravity had gained even a small advantage grew faster, pulling in surrounding matter, becoming gravitational attractors, embryonic galaxies. In contrast, emptier regions were left behind, expanding into the vast cosmic voids we see today. Randomness had given way to destiny. A universe that began almost uniform had split into a tapestry of light and shadow, density and emptiness, order and chaos. And yet, beneath all the physics, something more profound was unfolding: the birth of structure itself. Every atom was following a law older than time, drawn to its kind by a force it could never resist. The universe was learning to organize, to differentiate, to build. It was as if gravity itself possessed a quiet intelligence, a desire to transform simplicity into complexity. In those early epochs, randomness and precision became partners. The smallest fluctuations became the seeds of galaxies, and every ripple, every density peak in that primeval map of matter foretold the spirals, clusters, and black holes that would one day fill the sky. If we could have watched it from outside time, we would have seen rivers of matter cascading through the dark, flowing into the deep wells of gravity's creation. Invisible threads of dark matter stretched across the cosmos, weaving together like veins in a vast organism. Along those threads, gas condensed, stars flared, and the first cosmic filaments took shape. The universe was not expanding evenly. It was beginning to form a pattern, a great cosmic web, where matter flowed toward the nodes like rain into valleys. Galaxies would one day sit at those intersections, connected by filaments of gas and dark matter that stretched for millions of light years. But even as gravity built, it destroyed. The first massive stars that ignited also perished in spectacular deaths. their explosions sowing chaos in the very regions that had nurtured them. Shock waves from supernovae tore through the surrounding gas, heating it, scattering it, slowing further star formation. Creation was never gentle. For every cluster that formed, another was disrupted. Gravity had found its rhythm, a cycle of birth and collapse, harmony and violence. Scientists today can still read that ancient pattern. When they map the cosmic microwave background with exquisite precision, they find the echoes of those first whispers. Tiny spots, slightly warmer, slightly cooler, correspond to regions where matter was once denser or thinner. Those temperature variations are the memory of structure itself. Each pixel on that celestial map is a prophecy, describing where galaxies would form billions of years later. The entire observable universe, hundreds of billions of galaxies, grew out of those faint statistical wrinkles frozen in the radiation of the early cosmos. It's a staggering thought. All the beauty we see today, every spiral arm and every shining star, traces its lineage to randomness at the edge of chaos. A fluctuation that could have gone either way, a quantum tremor magnified by gravity's persistence, became a galaxy. And within those galaxies, worlds. And within those worlds, observers capable of asking how it all began. Yet the story was far from complete. As the first proto-galaxies took shape, something darker was stirring within them. The same gravitational wells that gathered matter also served as traps for collapsing stars. Each generation of supermassive suns left behind remnants, dense cores that refused to vanish. These black holes, small at first, began to sink toward the centers of forming galaxies, where they grew by feeding on surrounding gas. Some merged, combining their masses. Others tore through space, devouring what crossed their invisible boundaries. Gravity had birthed its opposite. Order had given rise to oblivion. And still, it wasn't enough. The young universe was brimming with potential energy, and gravity's work had only just begun. As dark matter halos merged, they drew in more gas, triggering bursts of star formation that lit up the darkness like cosmic fireworks. The first galactic mergers were both catastrophic and creative. Entire systems colliding, reshaping one another, their stars flung into new orbits, their cores compressing further. Each collision planted the seeds for the supermassive black holes that now anchor galaxies like ours. In this grand dance, there was no conductor, no divine blueprint, only physics, unfolding with a precision that felt almost deliberate. The numbers had to be perfect. Too much density, and the universe would have collapsed back into itself. Too little, and gravity would never have caught hold. The balance was razor-thin, yet it held. A cosmos fine-tuned for structure, where imperfection became the mother of creation. From the outside, it seems improbable, absurd even, that such complexity could arise from chance. But that is gravity's genius. It is the only force that grows stronger with accumulation. Every atom pulled by it strengthens it. Every success feeds the next. It is a feedback loop written into the very geometry of space. And from that recursive process, attraction breeding more attraction, came the first galaxies, their luminous cores spinning like wheels of time against the dark. We can still trace this heritage in the night sky. The cosmic microwave background is the ancient whisper. The galaxies are the echo, Between them lies the silence of 13.8 billion years, filled with nothing but the relentless persistence of gravity. It is a humbler creation story than myth, and yet no less miraculous. A universe where the faintest imbalance in the first moments of existence became the foundation for everything that followed. But gravity wasn't done. Its ambition ran deeper than stars and spirals. For every act of creation, it demanded a shadow, and as the first galaxies took shape, those shadows began to grow. The early universe would soon witness the rise of entities so extreme, so absolute, that even light would not escape them. Gravity had learned not only how to build, but how to consume. Before the first stars, there was only darkness, not the gentle kind that falls over a sleeping world, but a cosmic abyss that had never known the touch of light. The universe had expanded and cooled into silence. Hydrogen and helium gas drifted through the void like invisible smoke, spread thin across endless distances. There were no colors, no shapes, no warmth. For hundreds of millions of years after the Big Bang, creation paused in shadow. It was the great cosmic intermission, the era we call the Dark Ages. And then, somewhere in that eternal black, gravity found its voice again. It began quietly. The dark matter halos that had drawn gas into their invisible arms now grew dense enough for hydrogen to collapse inward. Slowly, the gas cooled, compressing into knots of ever-increasing pressure and heat. As each cloud fell deeper into its own gravity well, its atoms collided more violently, its center growing hotter by the moment. The universe was preparing to burn for the first time. But this ignition would not come easily. Hydrogen is stubborn. It resists fusion until crushed and heated to tens of millions of degrees. It took eons of patience and wait for the first spark to appear. When it did, everything changed. A single core reached critical temperature, and suddenly, atomic nuclei fused, releasing energy that pushed outward against gravity's relentless pull. A delicate balance was struck. The first star was born. It roared into existence, flooding the surrounding darkness with ultraviolet light so intense it could unmake atoms. The cosmic night was pierced by brilliance. After hundreds of millions of years of silence, the universe glowed again. These first stars, known to astronomers as population 3 stars, were unlike anything that would follow. They were titans, hundreds of times the mass of our sun, burning at unimaginable temperatures. There were no heavier elements yet, no carbon, no oxygen, no metals to help cool the gas. So they formed massive, unstable, and furious. Their lives were brief flashes on a cosmic timescale, lasting only a few million years before collapsing under their own weight. But in that short span, they transformed everything. Their radiation began to strip electrons from hydrogen across vast distances, ionizing the cosmos. The fog that once shrouded the universe cleared, and space became transparent once more. Light could finally travel unimpeded. This was the cosmic dawn, the end of darkness, the rebirth of visibility itself. But the beauty of their light came at a cost. These stars were not peaceful. Their gravity and radiation waged constant war, each struggling for dominance. When fusion at their cores could no longer resist collapse, they imploded with cataclysmic fury. Some detonated as supernovae so bright they briefly outshone entire galaxies. Others collapsed directly into black holes, devouring themselves in silence. Creation had discovered its cruelest rule. To build, it must also destroy. Every atom heavier than helium, every element of rock, metal, water, and flesh was born in that violence. Inside those blazing hearts, hydrogen fused into helium, helium into carbon, carbon into oxygen and iron. And when those stars died, their corpses scattered those elements across space. The ashes of their explosions drifted into the cold, mixing with the untouched hydrogen left over from the Big Bang. New clouds formed, enriched now with the seeds of chemistry. From that debris, smaller, longer-lived stars would one day form, and around them, planets. The universe was learning to recycle its dead. When you breathe, the oxygen that fills your lungs was once forged in such a furnace. The calcium in your bones, the iron in your blood, the gold in your veins, all were born in stars that died screaming. We are the living echo of their destruction, the memory of light condensed into form. Yet even as these first stars illuminated the universe, they were far too few to end the darkness entirely. They were scattered across the cosmic web like lonely torches in an infinite field. The regions around them glowed in expanding bubbles of ionized gas, while beyond those boundaries, the universe remained pitch black. The cosmic dawn spread slowly, a patchwork of light blooming in a sea of shadow. Over hundreds of millions of years, those bubbles grew and merged until the entire universe was rionized, transparent, awakened, alive. In this slow unfurling of light, something new began to happen. The first galaxies took on structure. The explosive deaths of stars sent shockwaves through their host halos, compressing nearby gas and triggering more star formation. Light begot more light. Star clusters merged, forming the first recognizable galactic forms: chaotic, irregular, and brilliant. The cosmos was beginning to resemble the universe we know, but wilder, more primal, and ruled by extremes. Still, the same force that had birthed this radiance was laying the groundwork for its opposite. The most massive of those early stars, collapsing into black holes, began to pull in surrounding matter, growing rapidly. These newborn black holes became gravitational anchors, settling into the centers of emerging galaxies. Over time, they would become the supermassive black holes that now dominate galactic cores, engines of both creation and destruction. The universe had learned to balance fire with void. As light spread, it revealed a paradox. The more the universe illuminated itself, the more it exposed its own emptiness. The vastness between stars and galaxies remained untouched, a cold, dark ocean surrounding islands of brilliance. For every star that flared into being, trillions of cubic light-years remained forever unlit. The universe was not a solid blaze of light, but a delicate lattice of fire suspended in infinite shadow. Creation had not banished darkness, it had defined it. From a scientific perspective, this era was a turning point. The rionization of the universe marked the final step in transforming raw chaos into an organized cosmos. Photons, once trapped in fog, could now stream freely. Gravity could sculpt galaxies more efficiently. Chemistry could take root. Yet, beneath that precision lay something ineffable: a sense that the universe had crossed a threshold not just of physics, but of being. It had gone from inert to awake, and still, it was fragile. These first lights burned too brightly to last. Their radiance tore apart the very gas that fed them, shutting down future generations of stars in some regions. Others were snuffed out by their own explosive deaths. For all their power, they were temporary. Bridges between darknesses. The universe had not yet learned sustainability. It was still experimenting, still stumbling toward balance. But those failures were necessary. Without the first stars exhausting themselves, there would have been no raw material for the next. Without destruction, there could be no continuity. The cosmos, it seemed, had written into its laws a cruel symmetry. Every act of creation demanded sacrifice. The death of one star paved the way for 1,000 new ones. And in that endless exchange of energy and matter, the universe found its rhythm. Over the next few 100 million years, that rhythm deepened. New generations of stars formed from the remnants of the first, smaller and longer-lived. These younger stars formed clusters, disks, and spirals, the first hints of galactic order. The explosions of the giants had enriched the universe with complexity, allowing cooling, fragmentation, and diversity. The darkness that once dominated now shimmered with countless points of light, a cosmos of depth and motion. Yet even as the stars multiplied, one could argue that the true miracle was not the light itself, but what it revealed. Contrast. Without the blackness, brilliance would mean nothing. Without collapse, creation would never find shape. The universe's beauty was born from its opposites. Fire needed the void. Existence needed extinction. Astronomers today look back at this epoch not just as a moment in history, but as a mirror. In studying the first stars, they glimpse the archetype of all life cycles: the rise and fall, the burning and fading, the tension between entropy and emergence. Every living thing, every world, follows that same rhythm. We are cosmic echoes of that first equilibrium, the balance between gravity's hunger and light's defiance. And perhaps, in that symmetry, there lies something profound, a message written in the physics of creation itself, that the universe did not stumble blindly into beauty. It was sculpted by the same principle that governs all things: transformation through loss. To die is to give shape to what comes after. To burn out is to illuminate the way. The first stars were not merely celestial furnaces. They were the first teachers, showing the cosmos how to evolve. In the end, their deaths were not endings but beginnings. Their scattered ashes seeded galaxies. Their remnants became black holes. Their light unlocked the universe's transparency. Every subsequent generation, every star, every planet, every life form would inherit the legacy of that fire. The Dark Ages were over. The cosmos had learned to shine, but it had also learned the cost of brilliance. And just as the first light revealed the darkness, the death of those primordial suns would open the door to something even stranger: the rise of monstrous gravity wells that would come to rule galaxies and reshape time itself. The age of stars had begun, but lurking beneath its glow, the universe was already preparing its next revelation. The universe had just learned how to shine, and already it was learning how to fall. In the aftermath of the first star's brilliance came their collapse, a cosmic reckoning where gravity claimed its full authority. Light, which had dared to defy darkness, now found itself devoured by it. The same forces that once forged illumination were now turning inward, folding space upon itself until brightness and matter were undone. And from that undoing, a new kind of structure was born, one made not of substance, but of absence. It began with the giants. The first stars, massive beyond stability, burned through their nuclear fuel in just a few million years, a heartbeat in cosmic time. Inside their cores, fusion had fought to push outward against gravity's crushing pull. But once the fuel was gone, pressure lost its footing. Gravity, patient, tireless, insatiable, seized control. The balance snapped. The star's outer layers cascaded inward at a significant fraction of the speed of light. Temperatures soared, atoms were crushed into neutrons, and the core imploded with unstoppable force. In some cases, the recoil of that collapse triggered a supernova, a detonation so fierce that it briefly outshone entire galaxies. But for the most massive stars, there was no explosion, no release, only silence. Their cores continued to shrink, compressing past all known limits until even atomic structure surrendered. Nothing could resist the crush. The matter that once radiated light became infinitely dense. Space itself began to curve so steeply that not even photons could climb out. A boundary formed, the event horizon, the last visible surface of existence before reality itself bent inward. A black hole was born. To the universe, it was something new, an object with no surface, no texture, no form. Defined only by its gravity, it warped everything around it. Matter drawn too close was torn apart, stretched into ribbons of energy by tidal forces that grew exponentially near its edge. Gas and dust spiraled inward, forming blazing accretion disks heated to millions of degrees. Ironically, these regions around black holes became some of the brightest beacons in the cosmos, a paradox of radiance born from consumption. In devouring, they illuminated. Millions of these black holes formed before the first galaxies had even fully assembled. Each one was a seed of darkness scattered through the young universe, invisible yet powerful, distorting the space around it and influencing how matter flowed. They were not destroyers, they were architects. In their gravitational embrace, gas was compressed, stars were triggered to form, and entire regions of the cosmos began to organize around their pull. The very engines of annihilation were becoming the blueprints of order. At the core of their mystery lies a mathematical singularity, a point of infinite density, where the known laws of physics collapse. Time and space cease to behave as we understand them. Equations diverge into infinities. Causality itself loses coherence. It is a place where relativity and quantum mechanics refuse to agree. A tear in our understanding of reality. To speak of a singularity is not to describe a thing, but the failure of all description. And yet, this impossibility exists everywhere in the universe. Scientists suspect that many of these first black holes grew quickly, feeding on nearby matter, merging with one another, and giving rise to the supermassive black holes that now anchor galaxies. But how could something so young, in a universe so new, become so vast? Observations of quasars, brilliant galactic cores powered by black holes billions of times the mass of the Sun, show that these monsters already existed less than 1 billion years after the Big Bang. Somehow, the seeds of darkness grew faster than light itself could spread. There are theories. Some black holes may have formed directly from collapsing clouds of gas, skipping the star phase entirely. Others might have been born from dense clusters of stars merging into one. Some might have been primordial, birthed in the first fractions of a second after the Big Bang, when the universe's density was so extreme that small regions could have folded into black holes spontaneously. If so, these primordial black holes could still wander the cosmos today. Relics older than galaxies, older than starlight itself. But beyond the science lies the haunting symmetry of it all. The universe began as light, but it was gravity, invisible, merciless, that gave it structure. The first black holes turned energy into architecture. Around them, matter accumulated, forming disks, jets, and halos. Where black holes merged, galaxies took shape. Where they grew, clusters followed. The voids, it turned out, were not empty. They were the seeds of form. From a philosophical view, this reverses everything we think we know about creation. We imagine destruction as the end of structure, yet the cosmos proves the opposite. Only through collapse does order evolve. Black holes, in their silent hunger, unify what they consume. They are the ultimate recyclers, taking chaos, compression, and death, and turning them into new equilibrium. Every spiral galaxy owes its coherence to the invisible monster at its heart. If we could fall into one, the experience would defy imagination. As we approached, the light from the universe behind us would bend and twist, forming a perfect ring, the so-called photon sphere, where light orbits endlessly before succumbing. Closer still, time itself would distort. To an outside observer, we would seem to freeze at the edge, suspended forever at the brink. To ourselves, the fall would feel swift and smooth, reality narrowing to a single point before vanishing altogether. No message could return. The event horizon marks not just a boundary of space, but of meaning. And yet, paradoxically, information may not be truly lost. Quantum mechanics forbids total erasure, insisting that every interaction must leave some trace. Physicists still debate whether black holes destroy information or encode it in the radiation they emit. What Stephen Hawking called black hole evaporation. If true, even these voids might one day fade, releasing whispers of everything they once consumed. Perhaps nothing in the universe is ever truly gone, only transformed beyond recognition. In the early cosmos, such transformations were rampant. As black holes grew, their violent interactions released vast amounts of energy, heating the gas around them and shaping where new stars could form. Too close, and their radiation sterilized the region. Too far, and matter cooled, coalescing into new generations of suns. This interplay between feeding and formation became the heartbeat of galaxies. Black holes, though small in scale compared to the vastness around them, dictated the rhythm of creation itself. If you were to watch from afar, the scene would appear both terrifying and beautiful. Light swirling into darkness, streams of matter drawn into glowing disks, then vanishing into nothing. Space would shimmer with gravitational waves, ripples in space-time itself, spreading outward from each collision of black holes. These waves carry the memory of cosmic violence, vibrations that we can now detect billions of years later. They are the universe's own recordings of its most cataclysmic moments. In their mergers, the cosmos found its geometry. In their silence, it found its shape. The great paradox is that what we call nothing is in fact a creative force, a sculptor working in reverse. Black holes do not add matter to the universe. They refine it, strip it down, redistribute it. The galaxies that would follow were not built despite them, but because of them. And so, in a sense, the first black holes were midwives of order. They imposed hierarchy and motion where chaos reigned. Their gravitational wells organized the flow of matter, setting the stage for spiral arms, star clusters, and cosmic jets. They defined the centers that galaxies would later orbit. Even as they consumed, they orchestrated. Even as they silenced, they gave rhythm to the universe's unfolding. It's easy to think of them as monsters, endless pits of gravity devouring everything. But that's a human reflex, born of fear of the dark. In truth, they are the balancing act that allows everything else to exist. Without collapse, there could be no cohesion. Without loss, there could be no form. The universe's story is not one of endless expansion alone. It is a dialogue between light and its absence. As time marched on, the first black holes continued to merge, growing heavier, more influential. The surrounding gas, drawn into their orbits, spun faster and hotter, emitting radiation across the spectrum. Some became quasars, blinding lighthouses that could be seen across billions of light years. Others remained quiet, hidden beneath veils of dust. But all of them, in their own way, were architects of what was to come. And then, against all odds, these voids began to build. The collapse that once ended light would soon give rise to something larger than any single star. The first true galaxies, anchored by the shadows that had once consumed their creators. Gravity's appetite had turned into its masterpiece. From darkness, structure emerged once more. Without black holes, there would be no galaxies. Without destruction, no creation. The universe had written this paradox into its foundations, and by the time the first billion years had passed, it was already clear that the dark hearts of space were not merely devourers, they were architects. What began as chaos and collapse had matured into design. Every spiral of light, every swirl of stars that now painted the cosmos was anchored to a shadow, and that shadow was alive with purpose. At the center of nearly every galaxy in the universe, our own included, lurks a supermassive black hole. These behemoths range from millions to billions of times the mass of our sun. Their gravity shapes the motions of stars thousands of light years away. Yet their story did not begin with grandeur. It began with hunger. The first black holes, born from collapsing stars or vast gas clouds, grew through a relentless process of accretion. As matter fell toward them, it spiraled into blazing disks of plasma, heated by friction to temperatures so high they glowed brighter than all the surrounding stars combined. The more they consumed, the more they radiated, until they became cosmic engines, transforming gravity into light. It seems impossible that something so destructive could also create order, yet this is precisely how the universe balances its equations. As matter falls inward, it does not vanish quietly. Magnetic fields twist through the accretion disks, launching colossal jets of particles at near light speed. These jets, shooting from the poles of the black hole, can stretch for millions of light years. Rivers of plasma threading through intergalactic space. They heat surrounding gas, stir galactic halos, and regulate the pace of star formation. Too much feeding, and the jets grow violent, blowing away the gas that would have birthed new stars. Too little, and the galaxy stagnates, drowning in cold dust. Somehow, through feedback and balance, black holes became the thermostat of the cosmos. This coevolution between galaxies and their central black holes is one of the most astonishing revelations of modern astrophysics. Observations reveal a tight correlation between the mass of a galaxy's central black hole and the total mass of its bulge, the region packed with old stars near the core. The larger the galaxy, the heavier its black hole, as though each knew the other's size intimately. The question is not whether they grew together, but how. The likely answer lies in feedback, the continuous exchange of energy between matter falling inward and energy blasting outward. The black hole feeds, then breathes, controlling the galaxy's metabolism like a heart regulating its pulse. Imagine it. Billions of stars orbiting like petals around an invisible stem. The black hole is the hidden center, unseen but indispensable. It commands not through light, but through influence. Its gravity sculpting orbits, its jets carving cavities in hot gas, its radiation shaping where stars can form and where they cannot. Galaxies, those graceful cosmic cities, are not random gatherings of stars. They are ecosystems, self-regulating, self-balancing, each one built around a dark nucleus that mediates between chaos and order. From a scientific standpoint, the mechanics of this relationship are breathtaking. As a black hole accretes gas, it radiates with extraordinary efficiency, converting up to 10% of the infalling mass into energy, a process far more effective than nuclear fusion. This radiation, along with the kinetic fury of jets and winds, can drive outflows that stretch across entire galaxies. Observations of active galactic nuclei show evidence of this feedback at work. Enormous cavities carved into galactic gas, regions where star formation has been quenched by the sheer power of the central engine. Paradoxically, by halting star birth in some regions, the black hole prevents the galaxy from burning itself out too quickly. It enforces restraint, ensuring longevity. In this way, destruction and creation are woven together. Black holes prune the cosmic garden so that it may flourish longer. They prevent galaxies from exhausting their fuel, allowing them to evolve steadily over billions of years. Without that regulation, galaxies might have burned bright and died young, collapsing into chaotic clusters of short-lived stars. Instead, we live in a cosmos of balance, where the death of energy ensures the endurance of form. Even on smaller scales, this dance is precise. The matter swirling near a black hole emits intense X-rays, influencing the chemistry of nearby gas clouds. In some galaxies, those clouds collapse under pressure, triggering new bursts of star formation at the very edge of the black hole's influence. A perfect metaphor for life emerging at the edge of annihilation. The line between nurture and destruction blurs, and the cosmos thrives in that uncertainty. To watch a galaxy form around a black hole is to witness a paradox made visible. From billions of light years away, astronomers see glowing rings of dust and gas orbiting unseen centers, jets lancing out like spears of light, shock waves rippling through the interstellar medium. Computer simulations bring this process to life. Filaments of matter streaming into dark wells, stars bursting forth, then silenced by waves of energy, only to be born again elsewhere. It is a feedback loop not unlike biology, where death feeds life and life returns to dust. Over cosmic time, these interactions shaped the great diversity of galaxies we see today. Ellipticals, spirals, irregulars, all owe their structure to how their central black holes fed and breathed. In the most massive galaxies, black holes grew so large that their outbursts quenched star formation entirely, leaving behind red, dormant giants filled with old stars. In smaller systems, gentler feedback allowed slow, steady growth. Our own Milky Way sits between these extremes, its heart harboring a black hole called Sagittarius A, a relatively quiet entity, now dormant but once active, shaping our galactic neighborhood. Philosophically, this partnership between creation and destruction challenges our deepest intuitions. We see darkness as absence, as loss. Yet the universe shows us that absence is a form of structure. The black hole does not negate existence, it defines it. Without its gravitational command, the orbits of stars would unravel. The elegant spiral arms would dissolve into chaos. The black hole's silence holds the galaxy's song in tune. It is the unseen conductor of the cosmic orchestra, ensuring that harmony can persist amid the noise. Even its violence serves purpose. Those relativistic jets, those blazing outflows may seem purely destructive, yet they distribute heavy elements across intergalactic space. They enrich the cosmic medium with carbon, oxygen, and iron, the ingredients for future worlds. Black holes do not hoard what they consume. They redistribute it. Their explosions of energy scatter the ashes of ancient stars far beyond their host galaxies, seeding the next generation of cosmic creation. Every atom in our bodies has, at some level, been shaped by their influence. As centuries of human study have shown, the more we learn about these entities, the less monstrous they seem. They are not cosmic mistakes, nor the remnants of chaos, but the inevitable consequence of order itself. Gravity, once unleashed, must find equilibrium, and in doing so, it builds structures capable of harboring life. The same gravity that ends stars also holds us together. We owe our existence to the balance it maintains between attraction and collapse, between light and shadow. In the grand scheme of things, galaxies are temporary sculptures. They will age, merge, and fade, but their central black holes will endure. When stars exhaust their fuel and their light dims, the black holes will remain, keeping the gravitational architecture intact. Even in the universe's far future, when galaxies drift apart and starlight fades, these dark hearts will persist, silent witnesses to the cosmos they once shaped. It's tempting to see this story as one of contradiction, but perhaps it's more accurate to see it as completion. Light and darkness, creation and destruction, expansion and collapse, all are facets of the same principle. Transformation. The universe does not choose one over the other. It weaves them together into continuity. Black holes are not anomalies. They are punctuation marks in the grammar of existence, shaping the rhythm of time itself. To stand beneath the night sky and look upon the Milky Way is to gaze at this equilibrium made visible. Every glowing star, every arc of dust, every quiet patch of darkness owes its being to that central void. The galaxy turns around a silence, a hidden truth that binds it together. And in that silence, there is meaning, Not the absence of purpose, but its essence, a reminder that creation is never pure, that even beauty must borrow from darkness. We live, quite literally, in the orbit of absence. Our home galaxy dances around a well of nothingness so deep that light itself cannot return. Yet from that void came order, and from order, life. It is not light alone that makes the universe. It is the dialogue between light and the dark that holds it in balance. The architects of this balance are invisible, yet their work endures across billions of years, sculpting the cosmos into harmony. Perhaps that is the universe's final secret, that its greatest creators wear the mask of destruction, that behind every gleaming galaxy lies a shadow, quiet and eternal, whose gravity shapes the dance of everything we see. And perhaps, in understanding them, we begin to understand ourselves, not as beings opposed to darkness, but as children of its design. There are more galaxies in the universe than grains of sand on every beach on Earth. Yet none of them drift alone. From afar, the cosmos might seem like chaos, countless islands of light scattered across infinite darkness. But zoom out far enough, and a hidden order emerges. A vast network of filaments, knots, and voids stretching across unimaginable distances. Galaxies are not isolated entities. They are the shining nodes of a grand cosmic web, woven together by threads of invisible matter. The universe, once chaotic and formless, has grown into something structured, interconnected, alive. This web began with gravity's first whispers. The same primordial fluctuations that seeded galaxies also extended across colossal scales, amplified by dark matter, the invisible scaffolding that gives the universe its shape. While ordinary matter formed stars and planets, dark matter remained unseen, its only signature written in the motion of everything else. It does not emit or absorb light, but it outweighs the visible universe 5 to 1. It is the skeleton upon which all cosmic structure hangs. Without it, there would be no galaxies, no clusters, no web-like tapestry binding the universe together. In the first billion years after the Big Bang, dark matter halos merged into larger structures, forming the earliest galaxy clusters. Gravity pulled matter along the densest pathways, funneling gas and galaxies into enormous filaments stretching for hundreds of millions of light years. Between those filaments opened vast, silent voids, cosmic deserts almost entirely empty, spanning hundreds of millions of light years across. The pattern is hauntingly familiar. Dense nodes connected by filaments, resembling the neural pathways of a brain or the mycelial networks beneath a forest floor. It is as if the universe itself had grown a nervous system. Where the filaments intersected, galaxies gathered into clusters, gravitational metropolises of thousands of galaxies bound together by mutual attraction. The spaces between them were filled with hot gas, heated to tens of millions of degrees by gravitational compression and the energy from active black holes. These clusters became the universe's great cities, each containing trillions of stars, thousands of black holes, and rivers of dark matter flowing invisibly beneath them. To look at one is to witness the universe thinking in large-scale structure, each galaxy a cell in a living organism of unimaginable size. Our own Milky Way is part of one such community. The local group, a modest cluster of galaxies bound together. Drifting along one of the filaments that make up a much larger supercluster called Laniakea, from our small corner of the cosmos, we orbit within an immense gravitational current, pulled toward a mysterious region known as the Great Attractor, where hundreds of thousands of galaxies converge. It's not a metaphor to say that the universe flows. It truly does. Galaxies migrate through space-time, carried by the gravitational tides of the cosmic web. Matter doesn't simply fall, it streams. The cosmos breathes. The story of galactic evolution from this perspective is not one of isolation, but of connection. Galaxies grow not just by forming new stars, but by merging with one another, trading gas and stars in slow cosmic collisions that can last billions of years. These encounters reshape them, transforming graceful spirals into chaotic ellipticals, sparking bursts of star formation and reigniting dormant black holes. Nothing in the universe stands still. Every structure, no matter how vast, is in motion, evolving through interaction. In these collisions, galaxies exchange not only matter, but also momentum and meaning. Two spirals may pass through one another, their stars seldom colliding directly, but their gas clouds colliding violently, compressing and igniting new generations of suns. Over time, their shapes blend, their cores merge, their black holes spiral together until they become one. A gravitational marriage that sends ripples through space-time. Each merger changes the architecture of the cosmos, stitching together small structures into larger ones, feeding the ever-growing complexity of the universe. Dark matter guides this entire dance. Simulations of the cosmic web show filaments forming first, like veins in a developing embryo, long before light could travel freely. Ordinary matter followed the gravitational contours, accumulating along these filaments, forming the luminous scaffolds we can now observe with telescopes. The invisible preceded the visible. It was dark matter that decided where galaxies would live, how they would cluster, and how the large-scale geometry of reality itself would unfold. What we see in the night sky, every nebula, every spiral, every flicker of light, is merely the visible surface of a much deeper, unseen structure. And yet, even this grand design is transient. The cosmic web, for all its immensity, is still evolving. As the universe expands, galaxies drift farther apart, clusters become gravitationally isolated, and the web stretches thinner. One day, in the far future, distant filaments will recede beyond the horizon of visibility, their light stretched into oblivion by dark energy's relentless push. The universe's great architecture will dissolve, leaving each surviving cluster to drift in lonely darkness. The connectivity that now defines the cosmos will fade, just as the connections between neurons fade when a mind falls asleep. But for now, for this brief epoch in cosmic time, the universe is awake. Energy flows through its filaments like blood through veins. Galaxies feed, collide, and recycle themselves, drawing on the gravitational resources of their surroundings. The intergalactic medium, once thought to be empty, hums with X-rays and radio waves, traces of the endless transactions between galaxies and the dark matter around them. Magnetic fields thread through space on incomprehensible scales, linking galaxies across millions of light-years. Even light, traveling for billions of years across these vast expanses, is bent and lensed by the invisible mass it encounters, revealing the contours of the unseen web through its distortions. This vision of the cosmos, interconnected, intricate, and alive, forces a shift in our perception of isolation. We are not beings lost in an empty void. We are participants in a network so vast that even the spaces between galaxies are rich with meaning. Every atom in our bodies was once part of a star, but every gravitational bond that holds us in place was woven by dark matter. We are children of both the visible and the invisible, matter and motion, light and shadow. It is humbling to realize that the same gravitational threads that bind galaxies also hold our solar system together, our planet to its star, and us to the ground beneath our feet. The laws that sculpt the largest structures in the universe are the same that guide the fall of an apple or the orbit of the moon. The cosmic web does not end at the edge of sight. It continues inward, fractal-like, all the way to us. Every act of connection, every force of attraction, is a miniature echo of that great pattern. Scientists can now map these colossal filaments through surveys of millions of galaxies, tracing their distribution in 3 dimensions. The result is breathtaking. A luminous, glowing lattice stretching across the observable universe, with clusters at the intersections and vast empty regions between them. Some of these voids are so large that light has not crossed them since the universe was young. They are the pauses between the notes of creation, the silence that gives structure to the symphony. Philosophically, this image of a cosmic web resonates deeply. It is a portrait of interdependence on a scale beyond imagination. Nothing exists alone. Every particle's destiny is shaped by its relationship to everything else. The universe is not a collection of separate objects, but a single, unfolding fabric of connection. Galaxies are not the exception to this rule. They are its expression. They reveal that complexity is born not from isolation, but from relationship, not from order imposed from above, but from the spontaneous self-organization of billions of interactions. And perhaps this realization touches something ancient within us. Across human cultures, we have imagined the world as a woven tapestry, a net, a web of being. Only now do we see that this was no mere metaphor. It was intuition reaching toward truth. The universe itself is a web, and every one of us is a vibration upon its threads. In this grand perspective, we come to see that even our solitude is shared. The galaxy we call home is one among trillions, yet it is connected to them all through gravity, through history, through time. We are the living awareness of those connections, the part of the cosmos that looks back upon its own structure and marvels. When we study the filaments, when we chart the clusters, we are tracing the veins of our own origin. But the web, like all things, is impermanent. The forces that built it will one day undo it. The galaxies that now move along its filaments will drift into eternal separation. The universe will forget its youthful networks and settle into stillness. For now, though, we inhabit the age of connection, the golden era when the cosmic web still hums with energy, when galaxies still meet, when light still travels freely between distant worlds. To gaze into the deep field of space is to see not just distance, but relation, a frozen map of billions of years of interaction. Each dot of light is not merely a galaxy, but a story of mergers, flows, and gravitational whispers. We are witnessing the universe in mid-conversation with itself, a dialogue written across eons. And somewhere within that conversation, tiny though we too speak, through our curiosity, our wonder, our search for meaning. In the end, the cosmic web is more than structure. It is a reflection of a universal truth. That connection is creation. From the scale of atoms to galaxies, from neurons to nations, life and matter alike depend on the threads that bind them. The universe grows not by isolation, but by entanglement. And though even these grand structures are only temporary, they remind us that everything we love, every bond, every orbit, every pulse of light, is part of one vast and fleeting masterpiece. Galaxies don't die. They drift into silence. The universe, once a storm of creation, is beginning to tire. The fireworks of star birth that once filled the darkness are dwindling, their embers dimming across the cosmic night. After billions of years of building, colliding, and reshaping itself, the cosmos is entering a quieter age, one where the engines of light slow, the gas runs thin, and the grand architectures of galaxies begin to decay. Creation, it seems, was never meant to last forever. It was a phase, a breath in the great respiration of time. For most of cosmic history, gravity and energy were locked in dynamic equilibrium. Stars were born in clouds of hydrogen and helium, burned their fuel, and returned their ashes to the void. Galaxies merged and grew. Black holes fed and regulated, and the cosmic web pulsed with energy. But all systems, no matter how grand, eventually exhaust their resources. The interstellar gas that once flowed freely between galaxies has thinned. The dense reservoirs that powered the cosmic dawn have been spent or blown away by the very stars they created. The rate of star formation, which once peaked billions of years ago, has now fallen to a fraction of its former brilliance. The universe is still expanding, but its growth has lost its fire. Across the heavens, galaxies collide. Not as violent explosions, but as slow, graceful dances lasting billions of years. The Milky Way and Andromeda, for instance, are on a collision course. In about 4 billion years, their spiral arms will intertwine like the fingers of ghosts, their stars weaving through one another almost without contact. Gravity will reshape them into a new, larger elliptical galaxy, its structure smoother, older, quieter. The fireworks of starburst activity will blaze briefly as their remaining gas compresses and ignites. But soon, even that will fade. What remains will be a red, swollen relic filled with aging stars, the last whisper of creation echoing through the void. These mergers are both magnificent and melancholy. When galaxies collide, black holes meet at their centers, spiraling inward as they radiate gravitational waves. Ripples in the very fabric of space-time. The waves travel outward, carrying with them the memory of cosmic motion, the last music of merging hearts. When the black holes finally unite, they form an even larger singularity, one step closer to the ultimate concentration of mass. With each union, the universe grows more organized in its structure, but emptier in its vitality. The cosmos, in its quest for equilibrium, is also building its own stillness. The same forces that once birthed stars now hasten their end. As gas is consumed or blown away, Galaxies can no longer replenish their supply. Star formation declines, and the stellar population begins to age. Blue stars, the hot, massive ones that burn brightly and die young, vanish first. Then the yellow suns fade, leaving behind cooler, dimmer red dwarfs. For a time the universe glows with their faint warmth, a twilight of aging light. But even those will one day exhaust their fuel, shrinking into white dwarfs, dense, glowing embers that radiate their remaining heat for trillions of years before cooling into black spheres of carbon. The night sky will look different then. Gone will be the spirals, the clusters, the luminous nebulae. In their place will hang red smudges of dying galaxies, isolated and drifting apart as dark energy accelerates the universe's expansion. The cosmic web will stretch thinner until its filaments snap, and each galactic island will become forever alone, separated by distances no signal can cross. Light from one will never reach another. The grand conversation of galaxies will fall silent. And yet, even this silence is not emptiness. It is memory. Every atom forged in those ancient stars will persist, scattered through the dark. The elements of life, once arranged in luminous order, will continue their slow drift through space. The black holes at the centers of galaxies will remain quiet and immense, holding what's left of their once living worlds in orbit. Some will merge, others will simply wait, patient as gods, as the last photons fade. These dark hearts are not the villains of the story. They are the archivists. Inside their gravitational depths, they keep the record of everything that has ever fallen. Entropy rules this era, the slow, inevitable slide toward disorder. But entropy is not chaos. It is change without renewal, the spread of energy until difference itself disappears. The heat death of the universe is not a sudden catastrophe, but a long sigh, a diffusion of all fire into the coldest possible stillness. In that far future, black holes will dominate, and even they will not be eternal. Over inconceivable spans of time, they will evaporate through Hawking radiation, releasing the last whispers of information they once devoured. The cosmos will fade to black, not as destruction, but as completion. Yet within that vision of decay lies something profoundly human, the reflection of our own mortality. Stars die, galaxies fade, universes cool, and so do we. Every heartbeat, every flicker of thought, is borrowed energy returning to the void. But like the stars, our fading does not erase what we've been. It transforms it. The atoms of our bodies will scatter into new forms. Our warmth will radiate outward. Our actions will echo in the lives we've touched. The universe teaches us that nothing truly ends. It only changes its expression. If one could look upon the universe's final chapters, it would be neither frightening nor tragic. It would be serene. The grand expansion would slow into stillness. Light would thin into whispers. What remains would be the faint afterglow of everything that ever was. A quiet field of memory, where energy and matter have become one. The same physics that began with explosion and light ends with balance and peace. It is not a story of loss, but of completion. Astronomers can already trace this trajectory in miniature. When they look at distant galaxies billions of light years away, they see the past, vibrant, full of creation. When they look at nearby galaxies, they see age, dimmer, redder, quieter. The universe is like a symphony heard from 2 points in time, its overture blazing with light, its coda dissolving into silence. We stand somewhere in the middle of that music, at the fleeting intersection between creation and decline. Even our own galaxy will not escape this fate. In the distant future, after merging with Andromeda, it will become a massive elliptical galaxy. Its remaining stars will slowly age and die, leaving behind only remnants, white dwarfs, neutron stars, and black holes. Over trillions of years, even those remnants will fade. The last light will come not from stars, but from the occasional collisions of dead worlds, or the evaporation of black holes. The final sparks will flicker like candles in a storm, one by one extinguished by time. And yet, perhaps, the end of creation is not the end of everything. Some physicists imagine that beyond the heat death, new quantum fluctuations could arise. Tiny pockets of order born from randomness, new universes budding from the ashes of the old. In that vision, the cosmos is eternal not in form, but in potential. Creation and decay become phases of a cycle too vast to comprehend. Every universe gives birth to the next, not as rebirth, but as continuation, the same energy taking new shape. If that is true, then even the silence at the end of time is not final. It is a pause before another breath, a stillness before another dawn. Just as the first galaxies rose from near-uniform emptiness, so too might future universes arise from the entropy of this one. The cosmos may be teaching us its deepest truth, that endings are beginnings disguised. Galaxies don't die. They transform. Their stars dissolve, their gas disperses, their black holes fade, but the memory of their light remains encoded in the background radiation, in the ripples of space-time, in the elements that once formed their bones. The universe itself is a memory system, endlessly translating energy into experience. And so the great collapse of creation is not a tragedy, but a revelation. The universe began as pure potential, reached its crescendo in structure and light, and will return, slowly, to stillness. Its journey mirrors our own, from chaos to consciousness, from brightness to quiet, from expansion to return. What we call death, it calls equilibrium. What we call nothing, it calls completion. In the final silence, when every light has faded and every atom has cooled, there will remain the faint hum of existence, the residue of everything that ever was. That hum will carry the memory of galaxies merging like ghosts, of stars exploding into elements, of minds that once looked into the dark and tried to understand. And maybe that memory, fragile and eternal, is what the universe has been trying to create all along. A way to remember itself, even as it fades into the long, endless night. Maybe black holes don't end universes. Maybe they plant the seeds of new ones. It's an idea that lingers at the edge of reason, half science, half dream. That what we call an ending might, from another vantage point, be a beginning unfolding in disguise. For billions of years, the cosmos has danced between fire and void, birth and collapse, expansion and silence. But what if this rhythm never truly stops? What if creation and destruction are not opposites at all, but two faces of the same endless motion, the universe exhaling into itself, forever becoming what it once was. Physicists have long wrestled with the mystery of what lies inside a black hole. General relativity predicts a singularity, a point where density becomes infinite, where the known laws of physics break down completely. But infinity in science is not an answer. It's a confession of ignorance. Many now believe that the singularity might not be a point of death, but a threshold. As matter collapses under gravity's infinite pull, space and time themselves may fold inward, until they reach a state so compressed that something new must emerge. Perhaps every black hole is a passageway, a womb rather than a tomb. In this view, each black hole could be a bridge, its event horizon the skin between one universe and another. The matter and energy that fall in may not be destroyed, but reborn, emerging elsewhere in some distant realm of space-time as a new expansion, a new Big Bang. The energy balance remains. The conservation of information holds, not within a single universe, but across a continuum of them. Our universe, too, might have been born from such a collapse. The final breath of another cosmos, whose stars died long before ours were born. If so, creation and collapse are not endpoints, but continuations, chapters in an infinite recursion of becoming. This is not mere speculation for the sake of poetry. In theoretical physics, ideas like loop quantum gravity, conformal cyclic cosmology, and black hole cosmogenesis explore precisely these possibilities. They suggest that space-time is not linear but cyclic, that the end of one cosmic era could trigger the birth of another. Roger Penrose envisions universes overlapping like ripples in a pond, each expansion fading into entropy, its radiation stretching until it becomes indistinguishable from uniformity, then reborn as the seed conditions of a new cosmos. Others imagine that inside the core of a black hole, quantum effects prevent a true singularity from forming, allowing a bounce, a reversal of collapse that ignites a fresh expansion on the other side. If these ideas are true, then the universe is not a story with an ending, but a symphony without a final note. Each act of collapse feeds the next crescendo of creation. Energy does not vanish. It transforms, reshapes, and reappears. Black holes, those terrifying voids of absence, may be the gardeners of eternity, sowing new realities from the remnants of old ones. Every spiral galaxy could be both cradle and grave, its central black hole not an executioner, but a midwife of what comes next. Even the flow of time may not be as linear as we perceive it. In a cyclic universe, the arrow of time, always pointing from order to disorder, from youth to age, might bend upon itself. Perhaps what we call before and after are illusions born from perspective. To a being outside of time, every collapse and every creation would be simultaneous, coexisting as a single eternal process, an infinite conversation between gravity and light. It is here, at the boundary between physics and philosophy, that the cosmos begins to resemble consciousness itself. Our own minds operate through cycles of creation and decay, neurons firing, connections forming, memories fading, patterns dissolving and reforming. The brain, like the universe, thrives in the interplay between order and entropy, between expansion and collapse. Perhaps the structure of the cosmos mirrors the structure of awareness, both self-organizing systems that find meaning in change. The universe could be not a mechanism, but an organism, endlessly regenerating through its own processes of death and renewal. If so, then every black hole, every galaxy, every atom becomes part of a vast continuum of self-creation. The builders and the destroyers are one and the same. The fire that births stars and the gravity that consumes them are partners, not enemies. Life, too, is caught in this rhythm. We rise, we burn, we fade, and in doing so, we give space for new forms to emerge. The symmetry is inescapable, and it is beautiful. Perhaps this is what eternity truly means. Not endless time, but perpetual transformation. Not a static heaven or frozen void, but a ceaseless unfolding of energy reshaping itself, forever new, yet never unfamiliar. The atoms in our bodies were forged in dying stars. The particles that make us may one day be drawn into black holes, compressed beyond form, only to burst forth again as the raw material of another universe. Creation is not something that happened once. It is happening now, everywhere, in every exchange of energy, in every collapse that gives rise to order. And when we look up at the night sky, what we see is not the past, nor even the present, but a living portrait of this eternal cycle. Every point of light, every dark void between them, is a reflection of that same principle, the endless dialogue between existence and absence. The galaxies shine not because they resist the void, but because they are shaped by it. The universe is not a battle between light and darkness. It is a love story between them. In the end, what began as a question, how galaxies and black holes formed, becomes a revelation about the nature of reality itself. Galaxies are not the opposite of black holes. They are their expression. The light we see and the darkness that swallows it are two halves of the same cosmic breath. One exhales, the other inhales. Creation is collapse, viewed from the other side. Maybe that is the final secret the universe has been whispering since the first flicker of structure. That nothing truly begins, and nothing truly ends. That every spark of existence, every fall into darkness, is part of a single infinite rhythm, the pulse of being itself. And if we listen closely, beneath the silence of space, we can almost hear it, the slow, eternal heartbeat of the cosmos, still breathing, still creating, still dreaming of itself.